Custom environments need custom tooling, and sometimes that starts right at the OS level. Well, that is exactly where Vultr Custom ISO support comes into play. Whether you are deploying a hardened Linux build, reviving a legacy OS, or rolling out a pre-configured appliance, Vultr Custom ISOs gives you a full control over your cloud instance setup right from the very first boot. Hello everyone, I'm Sanskriti Harmuk, a developer relations at Vultr, and in today's Tech Talk, we will look at what custom ISO images are, why they matter, explore specific use cases, and walk through a live demo of spinning up a Vultr Cloud Compute instance attached with a custom ISO image. So, without any further ado, let's get started. Custom ISO images are user created bootable disk images that let you take full control over your instance's setup. You can upload these ISOs directly to Vultr, attach them to Vultr Cloud Compute instance, and manually install your preferred operating system or environment. This opens up a ton of flexibility not just in what OS you use, but how you configure it during installation. It's an alternative to the built in marketplace OS images and is ideal for the setup that need more control, customization, or compliance. Custom ISOs let you break out of the constraints of default images. You can install any operating system, define your own disk layout and partitioning scheme, and even run legacy operating systems that aren't typically supported in modern cloud environments. Custom ISO images are also a great fit for teams working in regulated industries with strict compliance requirements where a full control over OS installation is non negotiable. You will commonly see custom ISOs used in a few specific scenarios. Custom ISOs are perfect when you need full control. You can deploy hardened or minimal OS builds, install legacy or niche OS versions, or recreate dev or test environments exactly the way you need them. They're also great for running tools or appliances that depend on specific OS configuration. So, if your setup demands precision from the OS level up, this is your go to route. Let's take everything we have just covered and bring it to life. In this demo, we'll walk through the process of uploading a custom ISO image to Vultr, attaching it to the Vultr Cloud Compute instance, booting into the installer, configuring the essential setup, and finishing the deployment process with chosen OS. Now, if your preferred operating system isn't available in Vultr's predefined OS options or Vultr ISO library, then you can upload your own custom ISO image directly to Vultr and configure it tailored to your specific needs. For this particular demo, we will proceed with Pop OS ISO image. Pop OS is an Ubuntu based Linux distribution for performance oriented desktop and workstations. What you are currently looking at is the Pop OS official homepage developed by System76. When I click on this download button, it will direct me to explore different variants of Pop OS. For this demo, we will go ahead with the latest LTS version for stability and long-term support. Now, when I hover over to this download button, it previews a direct link for our Pop OS version. We will right click and copy this link address for further use. Now, if you are unable to find the .iso direct link for your preferred OS build, then you can upload the ISO package directly to the Vultr object storage and retrieve the publicly accessible link generated by Vultr for this object storage and save it to your clipboard. Now, in order to upload the ISO image, we will head to the orchestration section on Vultr and navigate to ISOs. Here, as you can see, I already have an ISO image for Kali Linux. In order to upload a new one, we will click on Add ISO. In this field, paste the copied link. Please ensure that the direct download link has a .iso extension. Also, it corresponds to the version that you are intending to use. Now, click on Upload. This prompt message shows that the ISO image has been created successfully. We will go back to the ISO's page. Now, once the upload is done, Vultr will verify the file for format validity, integrity, and possible vulnerabilities. We will wait till it reaches 100% and become available to use. Once the ISO image is successfully uploaded, we will go back to the Pop OS website in order to verify the system requirements for our chosen OS in order to provision a compatible Vultr Cloud Compute instance. We will view instructions, and here we are able to gather that our chosen OS requires a 64-bit of processor, recommends 8 GB of RAM, and at least 20 GB of disk storage. Let's go to the Vultr dashboard. In order to deploy an instance, head to Compute section on Vultr and then click on Deploy Server. Here we will choose the server type, for example shared CPU. Then we will select a nearby location. And further, we have to select the instance size that satisfies the system requirement for our chosen ISO image. For example, here we will go with the 8 GB of memory and 160 GB of storage. Further, we will have to attach the recently uploaded ISO image to our instance. So for that, we will navigate to the ISO tab and here select the Pop OS ISO image. Further, you can also add the SSH key in order to establish an SSH session to access the instance and also add a firewall group. Please provide a relevant host name. And that's all that we need. We will go ahead and click deploy, and this action will launch a fresh Vultr Cloud Compute instance with a publicly accessible IP address. Please note that this will not contain a pre-configured username or password. Because we have attached a custom ISO image to this instance, we have to configure everything from scratch. Now that our cloud compute instance is up and running, the only way to interact with the Pop OS installer is through the Vultr Web Console. So here we will click on View Console. The boot process has already started. Please ensure that the custom ISO image that you select is UEFI compatible for the system to boot properly. Booting into installer may take a moment. The Welcome to Pop OS message indicates that we are on the right track. So the system has successfully booted, and this is the Pop OS live environment. But we still need to configure a few more steps. The installer will direct us through the installation process. So here, as we click on installer, we need to select the language. Further, decide on the keyboard layout. We will go ahead and choose clean install in order to utilize the entire disk. And here, as you can see, the Pop OS installation target matches our instance configuration of 160 GB of storage. So we will go ahead and click on erase and install. Here we will create a new user. Click on next. Provide a secure password. Re-enter that password. Click on next. Click on encrypt. And here we go. Now the partitioning of the disk, configuration of the system, and wrapping up of the installation process will begin. We are running a live CD environment, which means that the OS is temporarily running in memory and it has not yet been written to the virtual disk. Once the installation is completed, we'll go ahead and restart the device, and we'll also parallelly carry on a very important step in this process, which is detaching the custom ISO image from our instance. If the ISO image remains attached, then the system will boot from the installer again instead of the newly installed OS. So detaching the ISO image from the instance ensures that the system boots from the virtual disk. Now we will go back to the console. Here we will connect and enter the password in the prompt. The setup is successful. Now we will log in using the user credentials that we just created. Here we go. Enter the user password. And here is the fully operational Pop OS environment for us. Let's go ahead and check the network connectivity. This shows that the outbound internet access is working completely. Let's access the browser and visit a website. to verify that the web access is possible from within the OS. Now, in order to demonstrate that our operating system is fully operational within the instance, we will go ahead and install Nginx. We will further check the status of it. As it is running, we will go ahead and check out our instance, copy the IP address provided by Vultr for our instance, and open a new browser tab in our machine and paste that IP address. And here we get the default welcome page of Nginx. This indicates that our system is configured properly and is now ready to use. Now, you can install various software packages or run multiple services and even establish an SSH connection from your workstation to this instance. All the exercises that we have done indicates that the operating system has booted successfully, the outbound and inbound traffic is working properly, the network interface is also configured correctly, and the instance is accessible via the public internet. To wrap things up, we have seen how custom ISO support on Vultr Cloud Compute gives you the freedom to install any operating system, configure it exactly the way you want, and meet unique use case requirements. To try it out yourself, you can start by uploading your own ISO image and deploying it directly on Vultr Cloud Compute instance. To make it even better, you can use the custom promo link attached in the description below to get started with $250 in free credits on a new account. Thank you so much for tuning in to this Tech Talk. I hope to see you in the next one.